And here is our last section for the class. So this one is still on factoring, but this would be looking at a couple special cases. So you might remember, I'll write this up above here. If you had something like this, a plus b times a minus b, there's an interesting thing that happens because you do a times a is a squared, and then you would have negative ab plus ab, and then minus b squared. And if you notice the negative ab plus ab, that would add to 0. So you're actually just left with a squared minus b squared. And so if you recognize a difference of squares, then you know that they can factor into this form where it's an a plus b and a minus b. So you just kind of have to recognize whether it's a perfect square. So for instance, like 25. 25 is a perfect square. It's 5 squared. So in this case, you would have x plus 5 and x minus 5, right? Because those are perfect squares. This second one, we need to do a greatest common factor first. Boy, that's a little bit tricky with those numbers. Let's think of some examples. Like, for instance, what are they both divisible by? 200 and 128. Yeah, that one's going to take a little bit of thought here. Let's just try some numbers. So 200, obviously they're both divisible by 2, but I feel like we could probably go bigger than that. They're both divisible by 4. I wonder if they're both divisible by 8. 128 divided by 8. So that would be 16. And 200 divided by 8 is 25. I have a feeling that 8 is probably the biggest number. So let's factor out an 8. And then that would be x cubed also. That's common to both of those terms. And if you do 200 divided by 8, you get 25. And you had x to the 5th, but I factored out x cubed, so that would be x squared left over. And then negative 128 divided by 8, that was 16. Okay, so this one's a little sneakier, but we still have a perfect square, right? Because that would be 5x squared minus 4 squared. All right, oh, look at that. So we do have one of those difference of perfect squares, but we still have the 8x cubed out front. And then once we know what's being squared, those are the terms of your two binomials. A 5x, one of them is plus 4, and 5x, and the other one would be minus 4. And there we have it. So let's look at this situation. So this would be kind of similar to what we saw in the last one, but just for example, if I had a plus b squared, well, that would be a plus b times a plus b, right? A second time. So in that case, when you multiply that out, you would get a squared plus ab plus another ab plus b squared, right? If you map out all 4 of those multiplications. And so this time the middle term doesn't cancel out. It actually is doubled. So that's plus 2ab plus b squared. So this gives us a formula where if we recognize that the first and last terms are perfect squares, and that middle term is like double the base of those perfect squares, then you know it's going to be a perfect square binomial. Notice if it's minus in the middle, you have an a minus b. If it's plus in the middle, you have an a plus b. So in this case, it's kind of a two-step approach. Let's think about this. Let's just rewrite these as perfect squares the best we can. So like 4x squared would be 2x in parentheses squared, plus, I'm going to leave that middle term alone for now, leave a little space, and then that last term we see is 7 squared. So here we do have perfect squares on the first and last terms. And then so if it's a perfect square, if I have 2 times those same things that I just found as the bases of those perfect squares, that would be 2x and 7. If I multiply that out, 2 times 2 is 4. 4 times 7 is 28x. So that checks out. So the first and last terms are perfect squares, and the middle term is double the product of those two same numbers. So in that case, we know that this is going to be a perfect square binomial, and it was plus in the middle, so that's plus. And what goes in? Well, it's the 2x and the 7. 2x plus 7 squared. So that factors that way. Let's try this last one here. Again, start with the first and last terms, right? Because it needs to be something, and notice it's minus 2 times something, something, plus something squared. This is the structure that this is supposed to fit. So the first term looks like a 5x being squared. The last term is 6 squared. And if I do 5x times 6, that right there is 30x times 2 gives us 60x, just like we wanted. And we do have the negative already in there, so that'll take care of it. So it looks like we got that as well. This time, our perfect square binomial, since the middle term was negative, is a minus. And we just plug those numbers in, the 5x and the 6. All right. Hope you've enjoyed this lesson and all the others.